Okay, we're starting to talk about calculus, but this time we will emphasize the differentiation or first derivative. Do you know the difference between differentiation and the first derivative?
Well, first derivative is a result of differentiation. It's after you differentiate it once, it's first derivative. So I feel like differentiation is a
differentiation
process.
is different. Differentiation is
an operation.
No, you chop the functions. Okay, you chop the function small into infinitesimal.
Okay, and first differentiation.
First derivative is tangent. The thing is rate.
Oh yes.
First derivative is a tangent is a rate. Okay, that's you have to consider. So today we just talked about calculus, but we emphasize calculus, but we have differentiation. So the differentiation you have to make. So what is differentiation? Differentiation. Okay. So differentiation is a df. That's differentiation. Okay. The first derivative is first derivative. Can you see? You times dx. So the first derivative, what is the first derivative? First derivative is a rate. It's 2 rate. Can you see? Dx. So this is kind of rate. Rate. Okay. Differentiation is interval. Can you see? It's different. Interval. Understand?
Yes.
That's the difference between the first derivative and the differentiation. Of course, they are related. You see, we're talking about they are related. For example, when you do the integration, if you do integration in this case, so you always wish to find something. So this you're dealing with integral. You are always interested to know if this is someone's first derivative. For example, that's what we do. So if we say this is I know that we know that. See, this is of course you know that you solve the problem. Okay? But the trouble is sometimes these remain obscure
because it won't give you such a simple problem.
Now can we just use this formula here? If we use this formula immediately, we can rewrite that as a df over dx or dx. So two canceling process. Yes. Just tell you the principle is my way to deal with it. Cancel. So what you get? Yeah, that's right. You get f plus constant apart from. In that way, you got fx. Can you see? Plus c. That's important. So see. So and I will mention some concepts such as differential equation. That's another thing we talk about. So put this concept here. So another concept is a differential equation. Differential equation. Normally, these subjects were taught at the university level, but in IB, and they just talk about this high level. No, not calculus. Seriously, talk about. For example, what is differentiation? So any function. So any functions which you have involves the first derivative, okay. So for example, this could be another x here, and plus just make it simpler. Can get you to just write the abstract form. So this could be that be y equal to 0. This is the equation. Okay. Any equation which involves the first derivative is called a differential equation. You got it? Because we're going to talk about in this one. We're talking about. So if you see any of them, and this by way of the analogy, if you compare with our study of polynomial, then we can introduce a degree of differentiation. Oh. For example, this is if you see this one, this this one. So y dt square is actually this is actually that's called the second degree. Okay, so the first degree is a different degree. So the degree. So that's the first.
What happened to the x in the second degree? Disappears.
First, the second. Okay, second degree. Let me finish before you ask. Okay. So these are the example of the differential equation. We can solve it. Why? Because the objective is to find what y is. Okay, you want to find in this case, or y is yx or yt. We need to find it out. So how do we do that? We use integration. Okay, because if I rearrange that, for example, if we rearrange that one, so that becomes dy dx, right? dy dx will equal to omega squared divided by x times y. How can we solve that? Because we can just treat them as a two independent variables. So that's not dependent. So what we can do, we can separate them. Okay, the first step is to separate the dy. We divide by on both sides, and this side will become omega squared dx over x. Can you see?
And then you integrate
on both sides. So we just in this
omega is a constant, right? Yeah.
Omega is constant. Yes, that is. If you study physics, it has meaning. See, it's cancelled. No, not yet. Not this time. I'm wrong. So this time is not cancelled. Not yet.
It's
you can't be careful. You can log y. So that will give us. That is different. So that will be because log y equal to omega squared log x plus a constant. Can you see? Yes. So we solve it. Although at this stage it's explicit. Okay. We'll talk about more about these two concepts, the differentiation equation later. Let's just go to the old paper. Okay. If something's so simple, we're not going to study it. Okay.
We'll just start and then finish.
One of the typical questions is dealing with motion. Okay. Motion, yeah, kinematics. So basically, we know that x is not in general is a function of time, and the velocity is also is a function of time. We're talking 1D dimension, okay, and then acceleration is also the function of time, but they are related. So first, velocity will equal to dx dt, okay. How about a?
dv
dt or dx second derivative, second derivative, and t squared. So these are the bases that people often use it to ask. Okay. Now, sometimes, for example, in this case, in this first example that is given, that first example is given. We can try different ways. So given if v is given, so it's of course oh, that's very interesting. That is another way to solve it. Yeah, s is distance.
Yeah, I know.
Okay.
That's very common. They put s here. Yeah.
Now, before that, I'm not going to that example. Can we talk about some general case? Now, if you have a VT, this is explicit form. Okay. If you is given, then what can we do? We can work out the AT by differentiate, right, by find the first derivative of V. Then in this case, we can solve the problem. There's one way to do that. Alternatively, we can also use V to work out the displacement. Because why? Because, let me finish. Because by definition, so dx equal to v dt. Can you see? That's by definition. Can you see that? Can this differentiation? First derivative. Yeah. Okay. Can you see that? So therefore, then we're just integrate. We integrate that on both sides. We should be get to work out the distance. Or actually, it's called the displacement. But it is a straight line motion. Without the changing direction, that will be the same. So you can imagine that will be the track here. I just draw some properties so that you can. If just moving at one direction, this is x, this is position. This is origin. So this is the position here, which is a function of time. Now in this case, if you do integrate by both sides, dt, and then you can based on this function, you can get this x apart from the constant. See, apart from constant. So that will equal to v dt. Apart from after that, apart from constant. Then that one they will give you proper condition. For example, they will give you to solve this problem. They will say, our velocity at t equal to 0 equal to something like that, or then you can determine the c. Okay. Once you determine c, the function for x is given. So two usages here. Once v is given. So one v is given. There are two usages: to calculate a, or you can calculate x. Either way. Of course, sometimes if you don't know, another alternatively, they can say, I just expanded this question before you jump to that. Alternatively, that they're given something else, and this also give you acceleration. Given acceleration, say t equal to 3t, for example. So what can you do? What can you do?
Oh,
so you can
okay.
calculate velocity. So in this
equal
time,
to
because
dv
dv
over
equal to
dv.
a dt,
Yes.
so that's why you can solve, you can integrate on both sides. You see? Now in this case, a is time constant, time dependent. So you can't use, so that's, but still, we got a 3 here, I got a t dt. So what is that?
It's 3t
over
squared
2t squared
yeah.
plus constant. How about this side?
V.
This is delta v, change in velocity.
Yes.
Okay, and this will be asked mainly in relation to the diagram. So when you draw the diagram, this is most important. So if you have got the physics, so that if you have the velocity time graph, you have velocity time graph. Okay, if you got this curve, and then you should be able to work out the displacement by calculating that area. Do you understand?
Yes.
So you can calculate area by integration. Yes. So that's another usefulness of this. That is how we. Just give me a few seconds. Yeah, I think I'm getting very familiar with this path now. So that this area will get just equal to this area, because you just so that is area, because that's actually this area equal to that one. You see, by integration.
Is the tangent.
The
VT graph.
Oh yes, yeah. That's right. There's another thing is tangent. Yes, tangent. We're talking about that. Yeah, we'll talk about that. I don't make it too crowded. I don't have to make it more universe before we solve. But the question in this particular case, that's a bit twisty. So let's go to question 1. So what is given? So in this case, they have velocity equal to the distance, the function of distance. So there's, I think that to the 3x. I should put x here. It didn't mean the distance, but I might just put x here. So that is 2. They use s. I use x. Okay, just make sure. Okay. So then we'll say what will be the acceleration. So what is acceleration? So what is acceleration? You want to try?
Yes.
What is the relation between the velocity and a?
Well.
So a is a dv
dt. Yes.
So you just time dt on both sides. So you got the a dt equal to dv.
And then
okay.
You have that. Yeah.
That's
integrate
right. So
you don't integrate.
No. In this case, you integrate. You don't in this case. Okay, sorry. I thought they're asking for calculated something else. So that if that is the case, what can you do? So that is something you are looking for. Okay, but in this particular example, they have implied that both velocity and x are the function of time. Okay, both. So that is one. So x also is a function of time. Okay. So they are not constant. No. They are time dependent. Yeah. So what you do, then you can treat this as implied implicity function. Yeah. Okay. So that's what we do. So we just directly say we got because v equal to that. So therefore, so we need to find the dv dt. Yes. Okay. Now on this side, you can use product rule or quotient. I use product rule. I use product rules. I just treat that as a we just treat it as u times v, okay, and dt, I just do one, and that equal to u dv dt. Oh, hang on, I don't want to make confused. I don't write it directly because the v had been used. It's velocity. Sometimes I be careful if you didn't with that one, because I just write just apparent fact. So I first I keep that one, keep this one, or keep one factor. This one factor on move. And differentiate that one, that becomes 3, but be careful because x is a function of time. So you have to dx dt. Yeah. Oh, yeah, dt, okay. And then second term, because they have negative 1, so we got 2x minus 1. We write the original term here, factor rather. Yeah. So that would be 2. You have time 2. See? And then don't forget, you have to put a dx dt. Yeah. Because x are the function of time as general. So in this case, we got the 2 things. We got the cofactor here. So this is our acceleration now. So therefore, this is our acceleration. However, these are dx dt. What dx dt?
I have a question.
Yeah, go on.
Would this be log 2x?
No. We just do differentiation.
But if you differentiate this one.
1 moment. Okay, 1 moment, please. Can we? 2x minus, it's nothing to do with log. When you're doing integration, you have to consider log. So when you do differentiation, yeah. So in this case, that equal to 2. Can we expand it? That equal to 6. That is 6x minus 4. Okay, and that is 2x minus 1. We still have cofactor here. Now what is that? This equal to v. Can you see that is our v, is a function itself. Okay. Knowing that, they will help us to continue to simplify that. That be our v. Okay. And if still we can have the cofactor here. We still have cofactor here. So this is the same. We can do the summation. So we don't have to. We just finish this fraction difference. 2x plus 1. That is 3 plus 4 is 6. So negative 6, so that be positive 7. Do that? Minus 6x, 6 times x. Okay. Then we can use formula again. We use substitute the formula here, if you wish, right? That will what is v? That is v is given. So that will equal to 3x minus 2 times 7 minus 6x divided by this square. Okay, 2x minus 1 square. Yeah, any question?
You sure this is not 2x minus 1 square?
Oh, we have 2 here. I forgot. This is 2.
Yeah,
it's not log. It's power.
Yeah,
it's power.
Yeah,
it's power.
Yeah,
it's power. Yes, sorry. Yeah, that's in that case. It's not simple. That will change everything. This is square. Okay, it's not simple. Okay, we stop here because that is so simple. It's algebra issue. So this is not right. So we have to solve that. But that is essential. I put everything essential here. So you must recognize this is a v. Okay. And also we can use this, basically use definition to solve the problem. We don't want to spend too much time on that. So another way, we don't have to just go to next question. I think the next question is so simple. If the question is simple, we jump, okay? So in this case, they're given t, it's 2 functions. One's a log t. Oh, they use the log all the time. Secret t.
Oh,
yeah.
Before we continue on to the next question, I remember doing this question in class, and there's a simple way of doing it. So they write dv over dt, they use chain rule.
Yes.
Equal to dv over ds times ds over dt.
Yes, they can. I just return to the question, okay? Did you see that dv dx dt will equal to dv dx, okay? That's right. And dx dt. You can do that. Yeah, you can do that.
So basically, dx dt is v times v. So it's what you did.
Yeah, that's right. So that will equal to v dv dx. Yeah, you can do that. Dx. Oh, you can. Yeah, that's why you can stop there. You can stop there. That's right. But I wouldn't. Yeah, I wouldn't. Yeah, this is optional. These are optional, not essential. It's optional because we can. If you can, you can do that. Okay, can we just return to this question? We have limited time tonight. So this is simple. It's just straightforward. They ask you to find the first derivative and the second derivative. So just product rule. Can you see? Yes, I don't know. Do you want to continue?
No, it's okay.
No, it's simple. Yeah. And it also even ask you to find the first derivative.
That's fine. Yeah.
And sometimes we did this. We solved the problem before. When k is remember.
Go through it again, please.
Oh, this is just this number 3.
I try to do number 3.
Yeah, number 3. So the fx. So it is crowded. Let's go to the next one. So this question is fk. K is constant. It's just it's an integer. K is integer. So you got this function have the 2 different forms. One is x log x minus kx. Can you see k here? And that when x, I think this x is larger or equal to 0. Okay, this is 0, larger than. Not important. So basically, they're looking for find the first derivative. So sometimes I just use notation. Okay. Sometimes use a dx, sometimes use a df dx. Is equivalent. Okay. Now in that case, you just do it separately. Okay. And this is still 0, and this will be different. Because the second term will be negative k. I write second term here first, and here you use product rule. So you can we just keep that, so that be x divided by x. That's the first term, okay, and plus log natural log x. Okay, you can simplify that. You can simplify this. You can cancel that. Do you want to go further? No.
Oh, okay. Is that it? So you just figure it out?
Yeah, that's the first derivative. That's the first derivative. Okay. So just because sometimes you have to ask a question in relation to the k. For example, they say what would happen k equal to 0. I just write it down here. Okay. So it will be the log x plus x plus that's just 1, okay, yeah. Minus k. So in this case, they sometimes ask you, so how about the k equal to 0?
Then it's just log natural.
That's right. Yeah, they just substitute k because you get that's negative x minus 1, at plus 1.
Plus 1, yeah, that's it.
They just go on forever, okay. It's not simple, okay. And okay, they are looking for another thing they're looking for. This is something new. They have often like ask because in inflection, okay. Inflection is where we found the second derivative equal to 0, equal to 0. So that is how we have to solve that. But by solve that, we found x. Okay. So that were, you say, I'll give you a good example. Is that this is for example, you have the if you have the sine. Yeah, no, just like this one.
Okay. See, yes.
This is typically the inflation point. So in that case, inflation. So therefore, what I'm looking for, what they are usually looking for, is to looking for the what is x, what is this particular x at which. Yeah. So what you need to do is just for second derivative. And subject to use for 1, they must equal to 0. Okay,
well, they gave you the function, right? So
yeah, it gives the function. They gave the function. Okay, the function. So to summarize this one, you basically, it's important. We're going to talk about this
inflection point more.
No, we're talking about this the graph now. Graph is very important. So, but before that, can we just go on to topic number 5? Number 5 is displacement, but it's actually this. If you have started physics, you know this what it is. Okay. It's constant acceleration, see, yes. And a t squared. So that's why for people choose physics, that's very
half at squared.
So obviously this is quadratic, okay? It's quadratic. It's also therefore it's parabola. So sometimes you need to help you to draw the diagram, okay? When you draw a diagram, you don't want to spend too much time, but at least you can follow that, okay? You just use that is S, that is T, okay? Obviously, there's a maximum here, parabola, because this is Y, because A is not positive, okay? This A, so this is larger than 0, so that's bigger like they got this one, can minimum maximum. If they got the positive T square, you got positive, you got the maximum, right? Yeah, that's right. You got the maximum, so that's got right. Yeah, you are right. Yeah, and across the origin, see, across the origin here, projection motion. And by the way, this curve is similar to the trajectory of the project motion. Okay. But bear in mind, this use x, not t. Okay, so that's something you have to be careful.
Displacement time.
Yeah, displacement time. So this time they are looking for maximum. I just combine these two applications. It's called the x maximum. Okay, could be minimum. This is obviously so. This is when tangent. The tangent is very useful. They ask many questions about the tangent. And yes, there's tangent here. So they ask for the tangent line. There's tangent. Oh, we just use rich color. So there's tangent here. Tangent. So of course, if you're talking about tangent, then the maximum will be at maximum. There will be always first derivative to 0. So that is something first derivative at x0. So this is t. Okay, this is a particular t at t1 equal to 0. Okay, that is criteria to identify. It's called a turning point or minimum maximum as a turning point, and there's how to use the second and first derivative. Now, next one I found is very interesting because you have to be care must be taken. So they just draw this. I think for some students this is a bit strange, see, because you have to use you have to think very hard. See, after that I show you how to solve the problem using this. Basically, they got the first they got the first derivative. Okay, that's very strange, very strange. So for the first derivative, so they basically they got first derivative like this. Okay, so this is their first derivative. This curve is first derivative. Okay, you have to be careful as a function of x, and they're asking you what would be the function. What would be the function? So knowing the first derivative, what's the function? That's the algebra method. You must know the graphical method also. So how to sketch, how to draw the graph.
Something. One is at the minimum, it's a maximum or minimum.
So basically, they have two extremes. So basically, they have in this case they just. So basically, have identified they have the inflection here. Okay, that is a.
And the zeros.
So this is this equal to 0. Second derivative equal to 0. Okay, right? Yeah. Second derivative is, but this first derivative will correspond to extreme as the maximum or minimum, maximum, minimum. There are 3 of them.
Yes.
There are 3 of them. So from here to here, do you have trouble to work out the function?
If it's increasing, no, I don't have trouble.
How to draw this part?
It's a maximum here.
The maximum here, and how about this one?
Minimum.
Mm-hmm. This is minimum. How about in between? This is minimum. This is maximum. Okay.
And the inflection point, so it inflects.
Yeah, that's right. That's good. That's good drawing. Yeah, that's good drawing.
It's like the one you drew.
So that's right. So you have to be careful. You have to make sure because it's positive, it's negative, right? So you have to select this one.
Yes. And then inflect.
So that's right. Probably not. Just redraw that.
Probably more smooth.
Like this one. Okay. How about that one afterward?
Afterwards.
Then you got inflection here as well.
Yes.
So what would happen?
You inflect at this point.
So that's almost symmetrical.
Yeah,
almost symmetrical.
I think it's a minimum.
Yeah. But what about there has 0 at another extreme at this position.
That's another minimum.
Yeah. But we are not sure in this case. My guess is that one. My guess is 1. That's just because that's to make it 0 here. Okay. I'll be like this one. And then at a constant. Yes. There will be the constant, right?
Constant, yes.
This constant? No, it's parabola. That would be the parabola.
If that is constant, then this one's
that is parabola. That would be parabola.
I see.
Now this I found it a bit difficult to understand that I teach you how to do this because when I use my study, we use this all the time. That's I think would be useful if you
universities.
Because when I study the resonance, spin resonance.
In university.
No, during my study. In university, long time ago. So that is how to record where is draw the first derivative. So if you have originally, just do this. If you have originally have the Gauss shape, Gauss. If you originally have the you just take easy, get this one. If you have this symmetrical one, that's how I can. So that's also they got reflect inflection here.
And then you can have 2 bells. And
then the first derivative. Let me finish. The first derivative will be go to 0 here. Okay. So basically, keep the positive, but so the positive, right? So, but they got the heel here. They got heel here. So basically, got like this one.
And then the other one.
It's symmetrical because in this case, it's symmetrical. Don't touch. That's how the first derivative. Now, how about second derivative? The question
again, shorter wavelengths.
No, not wavelengths. With distance. Okay, let's talk about wavelengths. It's not wave. It's just the bell shape. This is y. This is y. This is x. This is the first derivative y prime. This is x, and this is the second derivative. Do you want to consider the second derivative? Do you want to consider that?
Yes.
Do you want to think?
Yeah, I know.
Go on.
Just 2 hills. They still.
Yeah. So let just me finish that. Okay, can we use the read one?
Yes.
Okay. So they got the cheapest one.
Yes.
They go to 0.
Yes.
Okay. So basically, what we have you got well, make sure this is consistent. That should be 0. Okay.
0, 1.
0. So
that
is be 0. So that be 0. That be negative 1. Okay.
Yes.
Okay. I hope this will help you to understand how to draw the graph, because sometimes you don't have to calculate. They will ask you. In this particular case, which can we compare? You see, that is how we, for example, if you compare with this one, that's why I use green for the first derivative. You will see the pump here, and in that you in the original function you got that increase. They have obviously the inflection here on both sides. Okay, so that I hope this diagram will help you to how to draw this graph instead of starting from this one a little bit abstract. And another thing is trying to I just go to another page. Another thing trying to ask you a type of question is to draw the you need to find the distance from origin. So this could be the origin. This is origin, okay? And there is a curve here, and they're trying to find the nearest distance. Sometimes they use L or can we call it L because the D for differentiation. So obviously this is P. This P point, X and Y, which is in this curve. It's called Fx. So you need to find this distance, which would be from the origin. Okay. So what can you do? So we know that the distance, do you know the distance formula? That's which question? This is question 7. So do you know the distance formula?
Distance formula?
Yeah. Equal to x minus 0
squared.
Pythagoras rule.
Oh,
the
okay.
Pythagoras rule. Okay, that is if the 3D, this is 2D. With this is 3D, you can go on for the to Z. So y squared plus z squared. But in this case, it's 2D. This is 3D. So this is 3D. So for the 2D, for this 3D. In the 2D, then we just L squared equal to, in this case, just x squared minus plus y squared. Pythagoras theorem. Okay. Now in this case, then we just have to bear in mind that this x, L is a function of both. So we will treat that L as a function. So you can solve that. That is square root x squared plus y squared. We don't have to. I noticed that we don't have to go to the so because we just solve net equal to 0. Okay. Important thing. Can we just do the differentiation to treat that as an explicit function of time? Okay. So no, not time.
Not time.
Let me see. Yeah, it's a parameter. We just also the other function of parameters. So given I write down here.
Lambda.
Yeah, it's just it could be lambda, could be x, could be
any symbol.
Could be any symbol. Can we put the time? Time is more reasonable parameter because we count the position in terms of time. Okay. You can use k as well, up to you.
But you used lambda.
Yeah, we use lambda. Yeah, we just use t because we use t to emphasize this time. It's more that gives you sense of motion. Okay, we're not dealing with abstract issue. So in this case, we can first find the first derivative. Say, do you know this symbol? Yeah, as well.
Dash.
Yeah, with dash. So first derivative is equal to -3, and z equal to 0. Okay. So in that case, we just continue our analysis here. Will be so we got 2L and dl dt. Okay, just use notation the better. 2x x dash the dot and plus 2y and y dot.
Yes.
Okay. Oh, hang on.
Yeah, y dash.
Oh yes, that's it's right. Parametrical. They are against time. I better choose this one. I better use explicit formula here.
And then we can substitute
that's right. dy dt. Okay. Then we can substitute the formula here. What is dx dt? -1. So the 2x. No, x is here. X to here. X to here.
Plus.
And the plus -6. Y. Okay. And this is our first derivative. And to make this equal 0, this must be 0.
Okay.
You see, to net the dx dt equal to 0, and then we have this equal to 0. Okay.
Why do we want to do the equal to
we
0?
found the minimum.
Oh.
So the distance for if you draw
at the minimum it will be the first derivative will equal to 0.
Yes, right. Yeah. So basically the distance in general you can, if you draw this function, that's a parametrical function. So if you draw another diagram, so graph will help you to understand.
I feel like this will be on our exam because it's a combination of vector
and so this is L, which is a function of t. So the distance were use different color.
Reach a minimum.
Yeah. So there has minimum, of course. That's where we're looking for. We're looking for there's a particular t. Okay. But also if the x satisfies this equation, that would be fine because x would be the function of t. So from here we can have so negative x equal to, can you don't move, can you please, 6y, okay, that would be x equal to negative 3y. So this is condition where the minimum happen.
Okay.
So we can substitute that to solve the t. Okay.
Mm.
So we have, so we basically x, we have one equation, x equal to 1 minus t, and y equal to 2 minus 3t. And we third equation we have x equal to negative 3y. So how many unknown? How many?
Three unknowns. Equation.
So that will not to work out the particular t.
And I can do the rest.
Yeah. Okay.
And then once you find t, you substitute it back into this equation
and find x, y.
Y
and this constant in this case. That's good. Another one, number 8. Number 8 is the given normal direction. See, so basically they given a normal direction. That's something you have to learn. So it's a straight line. Normal direction, tangent direction is a straight line. That is linear. It's a negative 3, 2x plus a constant here, b over 3. That is given. So basically what they're doing is that, so you got, so that you just draw it to graph. That will help you to understand what's going on here. So you got the curve here, curvature here. You got the curvature here, and you just saw the normal direction. What's the normal direction would be the one who perpendicular to that particular case. So that would be a normal direction. That would be the normal direction. Can depend on where. So this is normal direction. You can move around about it. That's normal direction. So how about tangent direction? Tangent will be this one. So if you just, this will be tan. So that's the perpendicular to each other. So that is very important for given the curve in the space in a 2-dimension or 3-dimension. You will always be able to identify at each point they got a normal direction, they got a tangent direction. Okay, this time, pay attention to this one. This will be the gradient of this normal direction. So this is y, this is x. Okay, so what they're looking for is that they give then they have the then there's a tangent. So then we have to, what is the function they have? The function they have is, I probably didn't copy that one. So the function will be equal to, I forgot it. I did copy the function. So I just write down here. So basically, I just give you the old general equation. Okay, which if this curve, we're talking about the curve now. If this curve is f, can you see? Or just called y. Okay, if yx, that's just for the curve now. Can we say it's xq minus says log x? Okay, just take it for example. So how do we determine there's a constant, how to determine the k? Or just to put a k here and put a k here. How do we determine k and b? 2 constant unknown? I think just 1.
So b is given? Or? I
think b is given. B is number 6. Or b is no. B is not given. So you need to find what the k is. So in this example, that is what is the k is. You know how to do that?
No.
So basically, you found first derivative dy dx. Okay, equal to 3x tan. That's right. that will be k over x, okay?
Yes.
And that will be the tangent
And it will be
of this one.
Yes.
So that at this particular position. So at this particular position, so this one, so this x1.
Oh, they will meet.
No. I'm talking about the tangent. I'm talking, this is the first derivative, okay?
I know.
The tangent, if you really want to write a tangent, what's the tangent? Tangent will be equal to this one.
Yes, I know.
That is 3x squared minus k
over
x, okay? That is the tangent.
Which is also the first derivative.
No. There's the first derivative time x plus a constant, plus a constant. But we only know normal direction. So what is the relation between the slope of the normal and the tangent line?
They intersect at 90 degrees.
Yes, but basically they say that the
cross product.
So they were simply equal to the reciprocal negative.
Oh yes, I know. I have heard.
So reciprocal negative. So 3, 2.
2.
So you have borrowed this. You have borrowed here. It's gradient. Okay, you have borrowed gradient here. So that we could negative positive. Okay, as 2 over 3. So then you can solve the k. Okay, you can solve the k. That we now to solve the k. Okay. Let's go. No matter, we will keep going for a while. Okay.
Oh, okay. Could you write down the equation in your box? Could you write down
which equation?
The gradient of normal direction equal to 1 over.
Okay. If this is a tangent. Okay. This tangent can we call the t tangent? Can we call the tk x plus b? Okay. And the normal direction we're equal to this tangent is normal x plus c. Okay. At the same point, so this k tangent were equal to negative reciprocal of cotangent.
I understand.
In other words, k tangent time k normal were equal to negative 1. So depending which way you easy to remember. Okay. So either way you should be able to remember this relation. They will ask them all the time.
Over and over and over.
Yeah, over again. Let's jump to 11 now. Let's just speed up a little bit because otherwise it gets very tight. That's 11. 11. So they have the volume this time. They have volume. It's a sphere. Yeah, it's a sphere. It's a sphere. It's something that they are dealing with a sphere, and the radius given. So the radius is r. Now what happens is they know the volume is changed at a certain rate. So,
so this is rate of
that's right.
Change
so
of rate
the
of
volume, V for volume, okay. Volume is changed as function of time. They will give the proper constant. Yeah, sometimes get just constant. So cm. Yeah. Forget about it. Yeah, they just use it. You don't have unified because math they just use also sort of unit. But in physics, in the physics problem, you have into the international system. Okay.
Meters per second.
Yeah. Given that one, so we have to find. They're looking for what they're looking for. How fast? What's the rate of change in radius? Okay, at a particular moment at r equal to say 2 centimeters.
I showed you the problem yesterday. It's similar to that. First, you find a relation.
Yeah, so yeah, that's one step one. Yeah, that's step one. Is step one. It just I know that. So step one is to find a relation, to find the dependence or relation. Okay, between r and v. So what v equal to 3? That will give you formula. So pi r cube. So therefore, we just do it against time. dv dt will equal to 4 pi and r squared dr dt. That's a very important thing. So you can solve the dr dt.
dv dt is given.
It's given. Okay. That's this question should be. If you have this, if you encounter this problem, you should get full mark. Full mark. Yeah. And what is this question? This question is a little bit different. So you can either, that's what we call. You can either use in this. This is a little bit a difficult one. Difficult because it's a little bit time consuming. Okay, you have to be patient. So in this time they have two. So basically, I draw this graph here. This realize what we're trying to do. So basically, you can, these arbitraries is just this is a cubic function. This cubic function. Just I just follow my notation here. It's cubic function. So basically, you can just this cubic function, right? Cubic function, and that you don't have to be very accurate. You just illustrate to help you to understand
the problem.
Yeah. So what do they know? What do they have? That this is this y, this x. Okay, this is yx. Yx is given. So the x cubed divided by 3 minus x squared minus 3x plus 4. That is the original question. Okay. So basically, they are still looking for. So there are 2 points here. So there are 2 minimum. So they have 2 minimum here. Can you see the 2 minimum here? One is called P, and that's called Q. Okay. So what they so then they connect these two with a straight line. Okay, this connect these two with a straight line. This is not a tangent line, just a straight line. Yeah, just straight line. So you can these 2 points with straight line. Can you see? Let's try that. Now they are looking for the equation of this straight line. Okay, there are 2 extremes here. There are 2 extremes here. Do you understand the problem now? So how to find the P and the Q? That is the first place to go. So basically what you need to do is that we need to find this particular P, okay, called x1, and this is x2, okay. So basically we need to find the derivative first, see, because this extreme, this tangent here is 0. So first, what do we do? So first we just use this d, find the first derivative first, okay. That would be 3 cancelled, right? That x squared minus 2x minus 3, okay? And the net equal to 0. That will solve this quadratic.
Okay.
We got 2 solutions, so x1 and x2.
Yes.
Got it?
Yes.
And then what do? We just assume that the 2 points will be on the same straight line. Okay. Now, this straight line can we call the y? Can we go to can we call it something else? Can we call the 1? Just call 1 1. Okay. Or just call y. Okay. Because we know this y is different. So this is straight line. So y. So the straight line y will equal to the gradient times the interception. Okay. Now, how do we determine these 2 parameters, k and b?
K and b.
Yeah. So we got
you have the gradient. K is
the
gradient.
So basically we can work out x1, y1 here.
Yes.
And this y. So this coordinate will be q. Q will be x2, y2.
Yes. And b is the intersection. X intersection.
Let me see. They were looking for the straight line in this form. So they are looking. They didn't say this form, but they are looking for this form. They are looking for ax plus by plus c. We can eventually after that, after we determine these two key parameters, we should be able to work out.
B is just the x-intercept.
The intercept when x equal to 0. Okay. So what can we do? So we first found the gradients. Okay, yes. I have the more complicated formula method, but I think we will not discuss today. We use a simple one. To do that, I just make sure that you understand that to find the gradients, in this case, gradients, we probably are not. We have to. I just redraw this diagram. What I do is that diagram. I just assume there's a straight line. I just assume that this is easier for us to interpret, to graph, to use the. I just assume that is our just hypothetically, okay. That is 2. If we got a 2 point here, we got with that P, with that Q here. Now in this case, how do we find the gradients?
Rising or wrong?
Yeah, that's right.
Delta
so that be delta y
over
and delta x. Okay. So therefore, k will equal to
y1 minus y2.
So y, yeah, that's right. y2 minus y1.
But y1 minus y2 because y1 is higher.
Well, that's something you can pay attention. I just give you a general idea. So that is how it could be positive, could negative. You have to be careful. Okay. Yeah, yeah.
Oh.
Okay.
Oh, but this one is negative. So yeah, you're right. y2 minus.
Now, if it depends, if this x2, that is 2 minus 1, you see, it's 2 minus 1, see, yeah. y2. Okay, based on this diagram, but based on this diagram, it's different.
Negative,
it's different.
Yes.
Okay. You probably have to refer to this diagram. Okay. Now that is how to determine the constant. But how to determine the final constant?
Final constant, just let x equal to 0.
Put
it into this equation or this one. Put it into this equation.
No,
x equals to 0.
No, you use this question. I just show attention. You don't. Once you're dealing with a straight line, you don't have to
use the original equation.
So you use this question. So you net x equal to 0, but you don't know y. You know the y equal to 0.
Oh, you have one of them. Oh.
You have one of them. Yeah. You have one of them. So what you do is equal. Oh, okay, that's right. That's how to do that. So basically, 1k is given, calculated. But when you calculate y2, you have to use this formula, okay?
Yes.
When you just have to, so you got 1, 2, I just give you 1 point here. Then you have, after that, you have to the y1 and y2 from this formula, from this equation.
Yeah, and then you can put a pair of them into this equation now that you have k to find b.
Yeah, so once you know kp, you just net y equal to 0. Equal to kx, right? Yeah. Y equal to x equal to? How to find b?
No, I'm just saying you can just put a pair of them. You can put y1 equal to kx1, and then you rearrange to find b. Because you know what k is. Yeah.
Okay.
Yeah.
Yeah.
All 4 of them are known.
Well, I hope you can understand that. I think we will. What time now? 6:30. Yeah. I'll just jump. Okay. I just jump one to this one. This is we have solved this problem equally. We have solved this similar problem before.
Oh, yeah.
Just trying to solve another problem, 13. So number 13, they have this, they have high percentage, probably 10%. It's a graphic, so you have to get it familiar with the graph, okay? So in this case, that's y, that's x. So they just give, in this time, they didn't tell you, they didn't ask you to solve that. It didn't actually use algebra. It just used a graph. So what is this question? I'm just trying to recall. So basically, at this is at a particular value here. They just have the derivative. Derivative. They found derivative. This is function. So I just draw that. This is function itself. Okay, let's draw the function. This is a function itself. So this is a function itself. So at this particular one, they go to infinity. Okay. So they're looking for the first derivative, right? Yes, first derivative. I think that is how the question. That's why I go back to it. Oh, yeah, this is a function. Yeah, that's right. This is a function itself. This is a function itself. So this is fx. Now, based on this one, they ask you to draw the graph, which is first derivative, absolute.
Yeah. Oh, absolute value. Yeah.
So what you do, I suggest you go to 2-step. Okay. Yeah. So there's x. That's the first derivative. What you do, I just follow this one. So can we just use different colors? If you're not sure, you can just use different. Yeah.
First.
Okay.
So at the maximums, it's 0.
There'll be 0. There'll be 0. So there's the first derivative. First derivative would be 0. Yeah. And also, so does this one.
Yes. Yeah. That's what I'm saying.
Okay. Is there and also equal to 0? 0. This is almost 0. Yeah, okay. That's all 0. So yeah. And how about that one? So the first derivative were like this.
It's increasing.
Yeah, increasing. I just put this one, so that will help you to understand. Different color. So the derivative will look like that.
Yes.
And then there will change. Can you see?
Decrease.
Decrease. And it became flat.
Yeah,
flat.
Yeah. Oh, that's a really cool way of using the app.
Okay, so eventually it became negative.
Yeah.
After that it became negative. Do they have okay, knowing that we were trying to diminish that. Okay, they're trying to work out the first derivative. It's green. So that's be 0 here. That'd be 0 here. That's the same. This is bound. We have the first derivative. So first to go up. Let's go up. So this is 0. There will be very high. It's already very high. Start from here.
Yeah, I think it goes down.
Yeah, it goes down. So it goes down like this one. So like this one, and go to there, and go to negative, and go down like this, and continue going.
Yeah, continue going down.
Go to negative and negative, and go for into the
infinity.
Into infinity, right?
Yes.
That's how we got to draw this one graph here.
And then here they start again. Like this.
Yeah, that's also this 0. Can you see? Yes. So that would be always positive degree.
Yeah. So it starts from here.
From positive.
From infinity positive.
Yeah, from infinity.
Positive infinity. Yeah. Decrease really fast.
To 0.
Yeah.
And then go to negative.
Yeah.
And go back.
To 0. Yes.
Go back. Okay.
C
is positive. Now, finally, we need to do absolute.
Then you just reflect it up.
You reflect up, so that's all right. Let's accept this part. And then we'll go up. Go up. And we accept that part.
Yes. And then that part reflect up.
Yeah, we accept this one, but they have to reflect. I think you are right. Okay.
I'm fine. But depends on if they ask for the absolute value of fx or the absolute value.
They are looking for this one, absolute of first derivative.
Oh, okay. So in this case, do we reflect it upon the x-axis?
Yes, x-axis.
Okay. But then when they have the absolute value inside the bracket, so if it's f absolute value x, then it's on that side.
On the y, it's symmetric to y direction.
And yeah, this one I got.
You know how to do.
It's like the camera problem.
How about this problem? Number 17 is slightly different. Let's go to number 17. Okay, so basically I draw the diagram. That's easy to draw with this graph. So we've got a y and axis, and they got a triangle. So you got a triangle here. The triangle is fixed on AB. So this has triangle here, which is isosceles, right? Isosceles. So basically, what I'm looking for, similar to the question you were talking about. So what is I talking about? This is moving downward. So this is velocity. So they can put the velocity here. So this velocity is downward. So this rate is given. So they are asking what is the rate of the theta.
Oh, okay. Angle.
Yeah, angle.
The first right relation.
So so this is angle theta here. So basically we have to, if this A and B, we know AB, we just go AB. So we basically half, so that would be
10 again.
This is y, can you see? Yes. This is y, this is y. So basically,
tan theta equal to.
So the tan theta is from the relation. Yes. Tan theta equal to y over half AB.
Yeah, half AB.
Can we go to L? Can we just support here? Some you are entitled to use your notation.
L equal to half AB.
Yeah, can you tell this L? Can you tell L?
Half.
Or you can even call half is L here.
Yeah. And then L equal to half AB.
Yeah, that's half. So F equal to half AB. L. So it's after it's constant, right?
Yes.
And then you find the first derivative.
Yes.
So this is relation. The first to find the relation.
That's very important. I think.
By the way, what is tangent theta?
Tangent theta.
Yes.
Oh, tangent theta. You told me already. It's log natural.
You have after that you have this theta, knowing that it is the function, okay, explicit function.
It's log natural cos.
No.
Wait, no.
You get confused.
Oh no!
It's a second.
It's
second square. Second square.
Oh my
God,
confusing.
So that's why. So that's why that's the d theta dt. We're equal to L is constant, okay? And the dy
over
dt.
dt.
So then you can solve
and
that.
you know what? Then you can solve for dy over dt.
How about this is same? Oh, these two are equally interesting. Do you want to do both? Yeah.
I'll do them too. What's the time? Do you have time?
I do have time. Can we finish this page?
Finish.
Can we see this page? Yeah. Yeah. We still have something interesting. But basically, you need to find the relation first. I think
That's
others.
finished.
Yeah.
Calculus. Differential equation.
Differential equation. Differential is simple. Just separate it. Differential equation is simple. We just fix these two. Okay. Quickly. So in this case, it got a circle. What number 18? They got a circle here. Easy to draw the circle. Circle here. So basically, they got a straight line here. They got the center. There's one here. There's one straight line, and
radius.
And this second, this is radius, and also there's also like this one. You have to do some. You have no geometry. Yeah, circle geometry is called circle geometry. Now, that's enough. So what we give in condition here is that this is a theta. This is theta. This R obviously. This R is the center. Okay, and they are looking for the T for the area. Okay. The area of this area, because so this area, okay. So this area, they use T, I use A, okay. A for area, easy. Then you could half. You know the trapezoid formula.
Oh yes, it's a side times
CB OA AB CB. That equal to the equal to. This will be the. Can you put this? Can we draw the vertical line here? Can I draw a vertical line here?
Oh yes. And
in the meantime, I draw another line here to help you. That would be that. Sometimes when you solve the problem, yeah, that's right. They will use this one. That is. Can you see this line? So that's become isosceles. So that we got another. This is called assisting line. So this R2. Can you see? So this right angle triangle.
What about this smaller triangle?
Yes, we're talking about that. We're talking about that. Basically, if you base on this information, or this is can we call it a hedge? It's called a hedge, and we only need to find the this side and this side. We don't need to have to put this one. Trapezoid is this side is equal to CB plus OA. Okay, I write a formula for you.
Times H.
And time H. Okay. So in our case, OA is R. OA is R, okay? Yes. OA is can we put R first? What is CB? CB is this side.
2R.
No,
it's a chord.
No, can we work out from here? So yes. This is half, can you see? Yes. Can we call this head? Can we call this A? Can we call it A here? So basically that R, so this A, what is A? So basically additional, so H over A will equal to tan theta. Okay. So therefore, A can be worked out. Yeah, so A will equal to H divided by tan theta. And this OA, CB is just equal to 2A. Can you see? Yes. 2A. In other words, the whole formula can, how about H? So that's H divided by 2. Yes. And that is, that's a very interesting formula, I can tell you. R plus, what is A?
A is H over tan theta.
I'm right? Probably not something wrong. H, what is H over R equal to?
H equal to R sine theta.
Oh, H can be worked out. H can, but this thing a little bit weird. So CP, what is CP? Oh, CP equals cosine theta. Oh, we can do differently.
So CP is A.
Yeah, okay. I give up. Okay, I found something more interesting. Yeah, more interesting.
Effective.
Make it related, you see. Yeah. That's because I use this one. A over R equal to cosine theta. Yeah. Okay. So therefore, A will equal to R cosine theta. Okay. Now, use this information with regard to 2R cosine theta. What is H?
H equal to
yeah, H, oh, I use a
Q
sign, yeah,
A tan
yeah.
theta.
Because H, so how about H also H over R equal to what? H over R.
H sine.
Yes,
theta.
good. So therefore H will equal to
R
R
sine
sine
theta,
theta. This is something, yeah. So we can substitute that into the formula. So in this case, we will get A equal to half. H is this one. H is R sine theta. Okay, plus R plus 2R is cofactor here. Cosine theta.
Ah,
That's interesting.
yes.
So we can R squared. So therefore A equal to R squared is constant. Divided by 2. Okay.
Yes, sine x, sine theta.
Yeah, that's sine theta. I will stop here because basically that is to give you the function. Okay. So what they do? They found this. Then they found the. Oh, they are looking for some extreme when this area is maximum.
Oh, so this is optimization.
The optimization. So this is a similar question. Okay, I just stop here. Just stop here.
So they want to find when dA d theta is at is equal to 0.
That's right. Last question would be 22. I think this is important. Okay, even I'm a little bit tired, I was trying to finish this one. So this basically you have the. Is this one similar to other one? Yes. Okay, I will keep at that. So basically there is a. It's very interesting. So basically someone is looking up the something which is could be the exhibition. Okay, you go to the bigger hall to show you saw the picture here. So basically I'm looking for this angle is a variable, this angle. So yeah, I'm trying to more optimize the angle here. So this is something I'm looking for. So this is just like someone look at this place, they have a picture here. So this distance is important. So what they do, they give the 2 parameters. One parameter is A from the ground, and O from the ground is B. Okay. So their question is that this as function of X. So basically, theta is dependent on X. So theta will depend on X. Okay. So they are looking for a particular angle, which is a minimum or maximum, I think. Yeah. So basically, that's when found this function. So that's part of application of calculus. So this all these are practical problems. Because this is theta x, this is x. Okay. Obviously, there at a particular x angle will achieve a certain maximum here. So this doesn't matter. But more important thing is they are doing that. They're just trying to ask students to find out where this tangent equal to 0. That's what I'm looking for. Okay, tangent. Oops, there's tangent here. Okay, here's tangent. So basically, they're looking for this particular x when tangent is a tangent equal to 0. The slope of tangent is equal to 0. Now, how to build this relation between x and theta? This right angle triangle, I remind you.
Oh, then.
Can we introduce another angle here?
Yes, we can alpha.
Can we get alpha here? Can we use tan?
Yeah.
By definition, how about the tan alpha? Tan alpha is constant.
A over x.
A over x, not constant. It's a variable too.
Yes.
Now, we don't know the theta, but we do know tan. Yeah, that's right. Theta plus alpha equal to what? Equal to B over x. Okay. Yeah. Now, then you have to use a little bit of knowledge of trigonometry. So here tan. That's why I don't recall. I don't memorize the tan. We just no. Yeah, is sum. Yeah. Here I just use sine. Okay. Equal to sine theta plus alpha.
Over
cosine theta plus alpha. Okay. Can you recall?
Cos
sine theta cosine alpha plus cosine theta sine alpha divided by cosine theta cosine alpha minus sine theta sine alpha. Okay. Now we have to substitute that one into our.
Do we know theta? No.
We don't. We need to find the theta as a function of x.
Okay.
Tan theta. These are given. These two are given. So what we do, we just rewrite that as one. Can we just divide this cosine? Okay. If you just divide every term by cosine, so that becomes sine theta. This disappeared.
Yes.
Okay. That becomes cosine theta and tan alpha.
Yeah.
Okay. We just go back again. So that would be cosine theta minus sine theta and tan alpha.
And tan alpha is a over x.
Tan over x. Yep. You can substitute that one. Okay. You want to go further or not?
Yeah.
So how did I solve? How did I simplify further? So tan alpha is given. So that is a over x over x. Okay, a over x. So we just now we focus on this one. Oh, by the way, this one, can you see we got equation? So these were equal to this side b over x. Okay.
Oh yes.
Okay, that were equal to sine theta minus cosine theta. What is tan alpha?
A over x.
A over x. Okay. So that's a possibility. I like this formulation because that will allow you to get familiar with basic relation in trigonometry. Sine, oh, this is sine, sorry, nearly finished. That will be sine theta, A over x. So what I could do, can we time x on both sides? So we got b, so that will, there's bx. So how about time x, right? We time x.
Oh, but then don't you want it as a function of x?
No, it doesn't matter. It's at most it's explicitly.
Oh.
It doesn't matter. So can we just explain time x? The time x will be how do we simplify? They will simplify this part. Can you see?
Yeah, but there will still be an x left.
Oh yes, that's sine theta x.
Yes.
Plus cos. That will be simplified.
Yeah.
A cosine.
Yeah.
A cosine theta, right?
I think bracket the whole thing times x.
Can we just simplify this part first?
Oh,
can we just time x here, time x here, all right? The x will cancel, so that will be x sine theta plus cos a, little bit tight, a cosine theta. We time x, okay?
And have another x. Oh, I understand
x cosine theta minus a sine theta equal to this one.
Yeah.
Yeah, well, anyway, that is how we eventually solve that.
And how do you solve this one?
You have to do the differentiation now.
Okay.
So basically, we just consider as explicit function. Okay. What we do is so we do the derivative against x. Okay. So when you see you are looking for dx. Okay.
Yeah.
And we net equal to 0 and found x to solve the algebra equation. All right.
Thank you.
So much for today, and we'll take a break now.